In this class so far, I don't think I've had you memorize much. I know I had you memorize 1 inch is exactly equal to 2.54 centimeters. Maybe some relationships in the metric system, but I'm not into memorizing. I'm more into kind of thinking through things. That's just how my brain works. Now, these are some things you're going to have to memorize, and I'm going to try to give you some hints about these polyatomic ions. I've already kind of showed you that you crisscross just the same if it's a polyatomic ion. If you need more than one, you have to put in parentheses and put it outside the parentheses how many you need. But you're going to need to know the name and the formula for these polyatomic ions. And I've got some flashcards that I think will help. And also there's something called Chem Mahjong that's really kind of helpful. I hope I remember to show you that. But I'm going to walk you through some polyatomic ions you need to memorize. Now, most polyatomic ions are negatively charged. Most of them are negatively charged. These are two exceptions. So actually, they're in your handouts for lab, you might have a list of negatively charged polyatomic ions, and I usually have people add this to their list. So ammonium is NH4 plus 1. We kind of talked about that. Now this is kind of an annoying form, I think, of mercury, in which you have two mercury atoms and they are stuck by sharing electrons, a covalent bond, and they are all running around with they're running around with a +2 charge. Kind of for that reason, and you can't split them up. They're stuck together. It's a unit. Kind of for that reason, I'm not sure, but basically we call that a mercury a mercury 1 cation. That's the name of that polyatomic ion. So most of them are negatively charged. Those are two positively charged you need to know. And then, and I'm going to show you a bunch of them that contain oxygen. They are anions that have polyatomic anions that have oxygen in them. These are some exceptions. These, of course, don't have oxygen in them, but you're going to need to know them. There's the cyanide ion, Cn-1, thiocyanate, SCN-1, and I like this one, the triiodide, where you have three iodines all running around with a -1 charge. Is that not cool or what? So you're going to need to commit those to memory. Okay, so I'm going to try to give you some hints, though. If you have a series of how do I say this? You have a series of polyatomic ions that have different numbers of oxygens. The one that has the most oxygen will end in ATE. The one that has the least oxygen will end in ITE. Now I see that here I have some, I don't know, we already talked about the cyanide, triiodide. This is an important polyatomic ion, the hydroxide ion. OH-1. Okay, this was what I thought I was a minute ago. So remember we had sulfite and sulfate, and the sulfate had more oxygens than the sulfite. Okay, so here we go. Here are some examples. There's our sulfite and our sulfate. Okay, not to be confused with, and I don't mean to throw you off, but sometimes I've seen students confuse this. Okay, what is the name of this polyatomic ion? Sulfide. That goes back to the mono, just one atomic ion. You get the -2 from the periodic table. Another series of nitrogen actually can have different numbers of oxygen atoms, and the one that has the more oxygen atoms, NO3 -1 ends in 8, NO2 -1 ends in 8. Notice that, and this is always going to be the case in the kind of corresponding series, they have the same charge, so that's kind of nice. Then we go to some kind of cool sort of oxygen combinations with the halogens, specifically just the chlorine, bromine, and iodine. they actually combine with 1 oxygen, 2 oxygens, 3 oxygens, and 4 oxygens. You're like, are you serious? So they have 4 different combinations with oxygen. Notice that they all have a what charge? They all have a -1 charge, so that kind of helps. Dead in the middle, we have our 8 and our ite. Okay, so ClO3 -1 is chlorate. ClO2 -1 is chlorite. Now, if you have a little bit less oxygen than chlorite, you add a prefix, so hypochlorite. Okay, if you have a little bit more oxygen than 8, you add a prefix, it's per, so perchlorate. And all of the halogens fall into line like that. Okay, then we have, these are just kind of hints how to maneuver kind of within families of polyatomic ions. So if your polyatomic ion contains, anytime it contains a hydrogen, it kind of bumps up a +1. Okay, so if your anion had a -1 charge, you pick up a hydrogen, and -1 + 1 is what? It's neutral. If your anion had a -2 charge, if you pick up 1 hydrogen, guess what? -2 + 1, now it has a -1 charge. And the other possibility is if it had a -3 charge, when it picks up a hydrogen, now -3 + 1, now it's running around with a -2 charge. So kind of think of that as you're adding a hydrogen, you're adding a +1 charge. So examples of that would be this one. So we have sulfite. We looked at that before, SO3 2-. If you kick in a hydrogen, what will be the charge? It will go from a -2 to -1. So now we have this hydrogen sulfite, okay, HSO3 -1. And yes, it kind of has, it's like a half, I kind of tease, it's kind of like a hyphenated last name, hydrogen sulfite. You might have learned this as bisulfite, I'm not sure. So sulfate does that too. We said that SO4 2- is the polyatomic ion sulfate. We can kick in a hydrogen, and then what happens to the charge? It goes from -2 to -1. Now it's kind of got that hyphenated last name, hydrogen sulfate, otherwise known as bisulfate. Carbonate does the same thing. CO3 2-, kick in a hydrogen, and now it's now it's HCO3 -1. Bicarbonate, hydrogen carbonate. Phosphate, then we get actually 2 times we can add hydrogen and still end up with a negatively charged polyatomic ion. So phosphate is PO4 3-. If we kick in a hydrogen, a +1 charge, what will be the charge now for hydrogen phosphate? It will be a -2. So HPO4 2- is hydrogen phosphate. By golly, we can kick in another hydrogen, and this actually has the fanciest hyphenated name of a polyatomic anion. This is dihydrogen phosphate. If we kick in 2 hydrogens, guess what? Now it goes to a charge of a -1 from a -3. So I hope that helps.